We are live now.
Good morning, everyone. Today, this bright day of June 2021. Very good morning to all of you. Today, we're going to look at how to convert our data into insights using visualization. So the topic of today's webinar is From Data to Visualization Using Python. We all know that each visual tells 1,000 words. What a visual can tell us, even 1,000 words are not sufficient to tell us that. And we also know that today we have a world full of data. We have an ocean of data. Just to imagine how big it is, every 60 seconds, we have 216,000 Instagram posts. We have 204 million records of emails. We have 72 hours of footage of YouTube uploaded every minute. And we have 277 tweets done every minute. And this is just the tip of the iceberg. These are just a few of the social media we've taken. Imagine the amount of work that is done online, the digital signatures that we are putting all over the place, the amount of work that is captured in digital form in offices, in governments, in all over the world to everything that we're doing. So we know that data is getting generated in huge amounts. So what do we do with this data? How do we handle this data? Because we need to have insight from this data. What is this data telling us? We want to find that out. So from data, we extract information. And from information, we extract insight. So how do we take this journey from data to insight is what we're going to look at today. There are three main ways of getting insight from a data. And all these three are very often used together. The first is to calculate summary statistics, such as mean, median, standard deviation, variance, and so on, and a host of other statistics that we calculate to try and understand data. The second method is to visualize data. We take these summary statistics and other measures and we visualize our data using charts and plots and graphs and maps. And the third method is that we run statistical models like linear regression, like logistic regression, decision tree, etc. A host of models that are available with us now. And we do all these three things to understand what is going on in the data. What is the relationship between variables? What is a particular variable telling us? How is it distributed? So today, we are going to look at the second point here, visualize data. How visualization of data can help us get insight to our data. So the agenda for today's webinar is how to choose an appropriate plot or a chart for my data, how to interpret common types of plots and charts, and what are the best practices for drawing these plots and charts. We know that data is everywhere and drawing plots, graphs, charts, and maps is a great way to make sense of it. So what exactly is data visualization? Data visualization is the graphical representation and presentation of data. And we all know how useful visuals are for understanding the data. Data visualizations are definitely having a moment right now because there is an ocean of data available. And one of the best examples of using data visualizations is our Google Maps. Maps we use, and maps contain such a whole lot of information, and it is visible on our mobile screens in such a short period, and it helps us to maneuver from one place to another, telling us a host of information that we would be using to go to our destination. So let's come to our first point of how to choose an appropriate plot. Now we have a host of plots. I've presented here just a few of them. There are innumerable types of plots and charts and graphs that are available. Just to name a few, we have the box plot here, a histogram, a line chart, a bar chart, a scatter plot, and so on. So which graph should be used for which kind of data? For example, a box plot. When should I use it? When should I use a line plot? Let's look at, so how do I choose an appropriate plot? Well, the very basic idea is that a visual depends on the kind of data we have. So for each different kind of data, we have different visuals. If we use the wrong visual, then the inference or the insight that is coming out from the data may not be correct, and we might not be able to uh, see the data in the right context. So it is important first to understand the kind of data we have and then to choose the visual. So what are the kinds of data? Let's understand that first. Broadly, the types of data or the kinds of data are two: categorical, or also called non-numeric data, and numeric data, numbers. So non-numeric data or categorical data would have categories, and numerical data might have numbers. In numbers also, we can have discrete numbers or we can have continuous. Let's look at them more closely. So a numeric data, also called quantitative data, could be in the form of a height, a weight of a person, the number of family members, number of defects in a machine, your account balance, number of students present in the class, production quality in a company, and so on. And non-numeric data, also called qualitative data or categorical data, would be information about the gender, about the city, about nationalities, and various other categories like medium, large, etc. So looking at numbers again can be, like we discussed, discrete or continuous. So height and weight would be discrete, would be continuous numbers, and number of family members or the number of defects or the number of cars would be discrete data. Because we cannot have 2.5 number of cars. We can have either 3 or 4 or 2 number of cars, and so it is discrete data. Here again we are presenting a data and we can see that we have certain columns of data. We have the name of the companies, company 1, company 2, and that would become categorical data. We have product, a column called product, which has names of products. So it will be retail, construction, healthcare. So that again will be category of data. Then we have revenue. We have expenses, we have profits, and number of products. All these 4 categories would be numerical data. And out of these, 3 are continuous data and 1 is discrete data, which is number of products. So either we have 1 product or 2 products or 4 products. It is not 2.5 products. And so we have discrete. So here, this is an example of how we see it. Now, how do we plot these data to figure out what is happening in this data set? Like we said, we have various options. So one is a histogram. Histogram is for a numerical data. And histogram tells us what is the distribution of the data. In a histogram, the y-axis is always the frequency. X-axis is the response time or our variable at hand. So response time is a numerical data, and we plot and see what is the frequency of various response time. Then we have the box plot. Again, box plot is also to see the distribution, and it is to see the minimum value, the maximum value, the median, the first quartile and the third quartile in the data. And box plot also tells us what are the outliers in a data. Again, box plot is used for numerical data. Other charts is a line chart. Very, very popular visualization tool is a line chart. And line chart is used for a time series in which we want to depict time. We take time on the x-axis and the other quantity on the y-axis. For example, produced sales, revenue, or any other number that we want to show, which is changing over time. Then we have the bar plot. Now, bar plots are used for categorical data. When we have categories on the x-axis and their scores or values on the y-axis. Now, very, very interesting plot, a scatter plot. What is a scatter plot and when is it used? A scatter plot is used when we have 2 variables. We can name them x and y, and we plot them and see the relationship. It tells us visually what even calculated figures like mean, variance, or correlation, covariance cannot tell us. A scatter plot can tell us that whether the relationship between 2 variables x and y, whether it is linear, curvilinear, polylinear, whatever the relationship is very, very easily available here. And also it shows outliers. If there is a group of values and one point is away from the values, then we know that this is an outlier data point. So we have listed here a few of the more popular charts that are easy to make and easy to understand. And we have listed here how and when can we use these plots. So now the second agenda item today is how do we interpret these common types of. So let's go to Python and look at these data plots in a case study and understand how do we build and make these plots. So we go to Python. Right, so we have here a small case study about, this is a data set about the tips provided in a restaurant when you have food. So whether you go for a dinner or a lunch, you provide tips. And this data set contains the amount of tip given and the amount of total bill amount. So we are going to use a Python program called Seaborn. It is a library, a very, very popular library of visualizing tool in Python. So first is we're going to import the Python Seaborn library. So we are clicking this cell. We have listed the cells here, and so we're going to load the data set, we're going to look at the data set, we're going to describe the data set, make some box plots, make some distributions, count the values, then make a scatter plot, correlation, some pair plots, and some line plots. And that is how we're going to learn today's visualization. Now, this Python notebook that you see has been made in Colab. Just like we have Google Docs and Google Forms, Google has also come out with a Python notebook called Colab. So we've opened this in Colab and we've written the codes in each cell. So we've already installed, brought here the Python library called Seaborn. And Seaborn has a database called tips, and that is what we are using. So in this cell, we are just we've just loaded the data set tips and saved it in a variable called tips. Now, this command tips.head lists my database. So here is my database. Now, by listing the database, the first 5 rows of my database, I can see what are the columns in a database, what are the kind of values that are available in my data. So here we have the column of total bills, which is a numerical column, which is a continuous numerical column. We have tip amount ranging from 1 to 3.6, some values like that. Then we have sex column in which we have female and male. We have smoker, yes or no. We have daytime, whether Sunday or Monday, and so on. We have a column about time, whether it is a lunch or a dinner. And we have the size column, which tells us how many people came in a group for dinner or lunch in the restaurant. So let's see, we have another command called info. We do that command and we see that we have 244 rows of filled in data set in our data set today. And we have these numerical columns have been saved as float category, which means can be decimal numbers, and size of the number of people who come in my restaurant in a group is also saved as an integer. Then the sex, smokers, and day and time at which we came is saved as a category. Like we discussed, a category or a non-numeric variable or a categorical variable. So this is how my data is distributed, and the function of info helps us to list all that. We also have another function, very, very popular function in Python called describe. So tips.describe helps me to list the data set. What do I see here? If you see, describe is only listing the variables or the columns in which the data was numerical. For example, total bill, which was float, tips, which was float, and size, which was integer. It is not telling me information about tip, size, sex, smoker, day and time, because these 4 are categorical and we cannot find out mean, median, mode of categorical variables. So here we are finding out mean, median, mode and maximum and minimum of a numerical variable. So we have mean, which is 20 of total bill. That means 20 is the average bill amount that people pay in the restaurant that we are looking at, the data set that we are looking at, the minimum that they have paid at any point from the time the data set has been collected is $3. The maximum bill amount that has come is $51. The maximum group size has been 3 people, and the minimum group is 1 person. 1 person has come to have dinner or lunch at our restaurant. The tip size, minimum tip size is 1. The average tip size is 3, and the maximum tip size that has been given in my restaurant is $10. Also, it gives us the medians and the quartiles. So this means that around 50% of of the people who come in my restaurant or in the restaurant in which this data set is from pay less than $18 for their dinner or lunch, and the average tip size is 3. So a lot of 50% of the people pay less than $3, and 50% of the people pay between $3 and $10. And here the 75th percentile or quartile 3 is 4, which means that 25% of the people pay between $4 and $10. Right? Let's go forward, build some visualizations here now that we know a lot about data. Here is the box plot. We're using sns.boxplot as our function. Here's a box plot. So we see that the minimum amount, the maximum amount, the outliers, the median, the first quartile, and the second quartile, everything is described in my box plot here. So all the values that were described here in the describe function have been given here in my box plot. Again, we see the box plot of we see the distribution, like we said, of total bill amount. So here it says the total bill amount. A lot of the people that come are paying a bill amount anywhere between 10 and 30. Few of the people are paying between 30 and 60. This becomes my distribution. Let's look at the box plot for tips. Here is the box plot for tips. So majority of the tips are coming. Around 50% of the people are giving tips between 2 and 4, because this is quartile 1 and quartile 3. So this is 50% of the people. Some people are giving a lot of tips from 6 to 10, but their numbers are less and they seem to be outliers in the general population. Again, the distribution of tips shows the same information in terms of the distribution. A majority is at between 2 and 4. Let's look at more information about my categorical data. So what does it tell us? Which days are more popular? My data set has 4 dates in it: Thursday, Friday, Saturday, and Sunday. So if you see here, it tells me that Friday is not a very popular day for people to come to the restaurant, but Saturday is a very popular day, followed by Sunday. Thursday also, there seems to be rush in the restaurant. And let's look at whether smokers come or non-smokers come. So in the data set, there are more non-smokers than smokers. Let's go forward and see about who is having a smoke more, whether it's female or male. In both the cases, it's the female in our data set are less, it seems, and so females are smoking less than males here. And let's see the size of per sex. So how many members are coming? So this data set tells us that around 1 to 6 people come in a group to the restaurant. Maximum values fall in 2. That means the maximum number of maximum number of people that come in groups, there are 2 people that come in groups. So the maximum group size is 2. Again, here males are paying more. So this column of tip is about the person who pays the tip. So male members are giving more tips than female members. And very few people are coming in groups of 6 or 5. 3 and 4, some is substantial, is a little better than the others, but majority are coming in groups of 2 to the restaurant. Then again, here again, females are less. Thursday, more females are coming, but on Saturday, Sunday, it's more males who are coming to the restaurant and giving tips. Let's look at the time. The time again is dinner time, more males are coming. At lunchtime, both female and males are coming in equal numbers. In fact, more females are coming at lunchtime than at dinner. Substantial difference between at dinner time between male numbers and female numbers. So that means at the restaurant, more male members are coming for dinner. So you see how, each plot is giving us so much information. Again, bill size. Are males paying us more or females paying us more? It seems males are paying us more, a higher bill amount. They're having a higher, maybe a more hearty meal or a more expensive meal at the restaurant than the females. Let's look at the total bill amount by day, by sex. So here also we see that Saturday, Sunday, or on all 4 days, it's the males who are having a higher bill amount each day. Uh, Again, bar plot for total bill time and sex. So again, here we see that there are more males who are coming for lunch and dinner, and more males are paying, even if more females were coming for lunch, but the payment of the bill is made more by the size of the bill is more for male members, both at dinner and at lunch. Even if females are coming, they are paying a lesser bill amount because this graph gives me the mean value. So when I say bar plot, it gives me the mean value. So this is the total bill amount's mean value. So more males are paying uh, uh, a higher bill amount than the females, even though in our previous chart we saw that more females are coming. Let's look at bill amount, size, and sex. Right. So if they come in groups, then for each group, male members are paying more bill amount than female members. And the bills are increasing as the number of people in the group increases, which seems illogical because there will be more bill paid if there are more members. Now let's look at a scatter plot. We discussed that scatter plot is one of the very, very important plots because it tells us the relationship between two numerical variables. So we have the tip here, which is the y-axis, and we have the total bill amount, which is the x-axis. Now, if you see the scatter plot here, very, very interesting here. There is a linear relationship. As the tip amount is going up, the bill amount is also going up. But at the same tip amount of, for example, we take the bill amount of 20. At the same bill amount, we have so many tips. So there is a variation in the tip. The tip at total bill amount of 20 can be 2 also, and it can be 4 also. So it depends on the person giving the tip. So there is a variation. And what is interesting here is that the variation increases as we go higher in the total bill. So if we go at a total bill amount of 40, so at 40 somebody can pay $3 also, $3 also, and they can pay $8 also. Now we want to see if males are paying more or females are paying more. So we add a hue of sex here, and this is what we get. So again, very, very interesting chart here. We see that at higher amounts, higher total bill amounts, we have mostly males who are paying the higher bill amounts, and females are paying the lower bill amounts and also lower tip amounts. So if you have a higher tip amount of say 9, it is mostly males, and it is for higher bill amounts of say 50, right? And most of the females are concentrated in here. So this is the kind of information that is getting generated from the visuals only that we are making from our data set. Again, correlation. We are making a correlation here between our various numerical columns. So there is a correlation between total bill size and the size of the group that is coming. 0.6 is the relationship. And also, which is understood, again, the bill amount and tip amount 0.67 is the relationship. Tip amount and size of the group. Very interesting here. It's 0.5. There is a 0.5 relationship between correlation, positive correlation between tip and size of the group that is coming for dinner. We are going to see the same relation in a heat map. What a heat map does is it gives color to the correlation. It also provides me the value that are present in this chart and also gives me the correlation. This is my heat map. It also colors. And if there are too many variables, if there are 10 to 12 variables, the heat map really helps us to visually see which are the highly correlated variables using the color scheme here. Again, pair plot, very, very interesting. We have the same correlation information in the pair plot. So here we have pair plot. And if you see the pair plot again, it tells me the correlation scatter plot for all the variables, the numerical variables, and it also tells me the distribution. So blue is the male and orange is the female. So if you see, total bill amount for all males is higher. Tip amount also, it's higher, substantially higher for males compared to females, and size of the group in which they are paying is also much higher for males than in females. And that is what my data is telling me. So again, scatter plot, pair plot, heat map, all these tell me correlations. All these three together gives me different ways of looking at correlation, the relationship between two numerical variables. Very, very interesting and very, very handy tool. And you can see that Seaborn is such a versatile uh, uh, library that by just one line of code, I'm able to see such expressive plots. Let's look at a plot in which I'm seeing the relationship and also the size of the group. So this is the male. The males are scattered. We saw it in the scatter plot. What we've added here is the bill size. So bill size is depicted by the the group size. Sorry, the group size is depicted by the size of the bubble. So if the bubbles are higher, we have higher. If the group size are bigger, then we have higher. So this gives us more information. So if at higher levels of bill size, so bill is not just increasing because of the number of maybe expensive dishes. It is increasing more because there are more people in the group that is coming to have the food at the restaurant. Again, we have a very just like Seaborn, we have a very interesting library called Plotly. Now, Plotly is a private company that provides us Python codes for looking at graphs. And if we see here, very interesting graph here, it's a 3D graph. So what we've done here is that we have looked at we can maneuver this 3D plot. So we have here total bill amount on the x-axis, total tip amount in the y-axis, and the size of the group as my z-axis. I can move this around and I can see. You can see here also that, and also male and female. So red would be the males and blue would be the females. So I can turn this around and interpret my chart in whatever way I want to. And again, you can see that with just one line of code, I'm able to make this complex chart in which I'm able to see the relationship between the variables. So if we see here, we see that at a total, group size, at a group size of 2, a lot of people are coming, both males and females. And how many tips are they getting? They're giving the tips in the same, almost the same amount. Almost the same amount of tips they're giving. We can just put it like this. So X is my total bill amount and Y is my tip amount. Right. So for each group at 2, we can see this line. So it's divided into these group. Very few people are coming with a group of 6 that are giving me tips at a higher level, right? So these were examples of how we can make these scatter plots using SNS. Let's go back to our presentation and see what are the best practices. So what are the best practices of making these charts? So if you want to know more about Seaborn, you can visit their website. There's a whole lot of information on how to make charts and plots at Seaborn, and you can look at the gallery there and learn more about it. Now, for understanding the best practices, we have listed 10 core principles that we should implement during the visualization process. So let's look at these core principles. The first is the data should be presented in a very clear possible. The x-axis, the y-axis, the legend, the dots, the data sets, everything should be very, very clearly visible. We should not make a jumbled up effort. Again, we should reduce the clutter. Instead of having too many lines, it should be neat set of lines that are shown to give the crux of the visual or to present the effort, present the main point in the visual. Again, to present the main point, the third core principle is that we should integrate text and graph. We should have a title. We should describe what's happening there, the x-axis, the y-axis, the series, the index, the color scheme. Everything should be looked at. The fourth principle is that we should look at the pre-processing, how the chart is made. So what does pre-processing, what are the things that we should keep in mind in pre-processing? The shape, the enclosure, or the line width, the saturation of the colors, the actual colors, whether it's a 3D, how can 3D be presented, whether it's a 2D chart, what are the positions of the various items, what is the orientation, the markings, the size, the length, the curvature, closure, sharpness. All these aspects have to be looked at when we are doing visualization, and we should pay attention to these aspects. The fifth core principle is that we should keep the audience in mind. What kind of audience is looking at the visual, whether what kind of stakeholders are there, whether those stakeholders have awareness of a box plot. If they do not have awareness, can I present a bar plot? Can I present a distribution? Will they be able to make sense out of it? How do I present a map? Should I present a map? So all these things should be kept in mind too. So you should keep the audience in mind when making a visualization. Again, annotation is very important. What are you trying to say in the graph should be clearly visible and explained. Seventh point that we see is that bar charts. Very, very important point. Whenever we make a bar chart, this is a very popular chart type of visualization tool. We should start from zero. So if you look at these two figures, this looks like there's a huge gap between these two segments or categories. But if you start the value from zero, the difference is not very substantial. So if you go, bar charts are used exclusively, extensively in, say, your figures for elections. So just if somebody wants to show that there is a huge margin between the winner and the loser in elections, they will use this graph. And if they don't want to show that there is a huge margin, they might use this graph. But the more appropriate the appropriate graph to use is this graph, because it should start from zero. It will present to you the actual picture between the margin of the votes that got the winner and the loser. Here it is not presenting me the actual picture because it is not starting from zero. Again, these things have to be kept in mind for bar chart. Pie plots and maps also are huge care that needs to be taken, because it is very, very easy to misinterpret them. And so many times people who make it are also not aware that they are making a mistake. So pie charts and maps, for pie charts is the percentage of. So percentage of what should be clearly defined, and all those percentages should add up to 100. If these two conditions are not met, pie charts would be a wrong choice in that area and will be losing the context, will be giving incorrect insights. Again, maps. Maps are very tricky, although they are very good tools. Tricky in the sense of having the scale. So this should be scaled properly. If they're not scaled properly, they will give an image of having a wider area and a smaller area, which is not correct according to the scale. So these two should be taken care of. Again, ninth core principle is label. Use labels, use descriptions, tell what is a bar or a chart telling us about. And finally, the most important core principle is build your story. Whenever you are doing visualization, what is your story? So for example, in this chart, we see that there's a huge decrease in the stock market during our February-March 2020, and then it caught up. So if you want to focus on the change in the stock market values at NSE, you can highlight it and build your story that the reason why this went down during February-March was COVID that hits the stock market, that hit the country and the stock market. So building a story, once you have all the previous core principles in place and you know the context for which you're making visualization, then building a story comes easy. So if you want to know more about data visualization using Python, then you should visit Matplotlib and Seaborn websites, which will give you more information. And just to wind up before we go, let's look at some data visualization tools. Plotly, we just use Plotly in our Python notebook and Colab, and it is an enterprise solution for making visualization tools. So enterprises are using Python to make tools for companies and corporates to visualize their data on a large scale and use easy visualization. So Plotly is one of the most popular tools in the market, and they have a enterprise version called Dash. So what we used just now to make the 3D plot is also a Plotly a Python code that we used. Then Tableau, one of the most important and popular and very easy to use tool that we can all learn and use to become experts in. And there are a whole lot of jobs available in Tableau. So you need to know the data, you need to know the structures, you need to know how to build the data, and it comes very, very easy. It gives you a whole lot of visuals ready to use at the click of a button. Then there is Click. Is also becoming very popular, and a lot of companies use it. We have Fusion Charts, again a very popular site, and a lot of Python code is available for us to build on our own also, and companies use it a lot to make their data visible and find out insights from the data. Then we have High Charts, again a very popular tool, and we have Data Wrapper. So all these tools are available in the market that companies are using, and they need people who can make these charts, use these tools, and derive insight from the data. So that is all for today's presentation. Thank you very much for your attention, and hope you benefited about how visualization can be used to create more insight from the data. So any questions you have? All right, thank you very much for looking at the presentation, for spending your time. Thank you.